Welcome to the video solutions for day 2 of Barvember. As yesterday, just a quick reminder that the best questions for learning to use bar models are ones that you think are easy. So don't worry that this might be a simple question and you don't need bar modeling to do it. If you can solve the problem easily, then that will help you see what you need to do with your bar modeling. Now here's the first element of any bar model, which is that numbers are represented by bars, and if we know what that number is, then we write it in the bar. Our second key element is to make sure that we label our model so it's clear which part it is. So we need to know which part is Eva's and which part is Rosie's in this question. Now here's another of our bar model elements, which is the double-headed arrow. And this represents the difference between two bars. Now the difference between two numbers is the amount by which one number is bigger than the other or which one number is smaller than the other. And we can see in the question here is this is how much more. So how much more is Eva's number than Rosie's number? And the really important element of any bar modelling picture is the question mark, which shows what it is that we're trying to find out or solve. And in this instance, it is the length of this double-headed arrow. So how much more does Eva have than Rosie? And from the picture, we can see that this is a straightforward subtraction question. And you can follow the working through there yourselves. Question 2. Quick question to ask yourself at the start of any bar modelling question is, how many bars will I need here? Now, this question is about two numbers, so I'm guessing we're going to need 2 bars here. Really important bar model element here is our curly bracket, and this is telling us to total, add, or sum the values in the bars that the bracket covers. So this is dealing with the first line here. The sum of two numbers is 50. Sum means total, adding up. And we see our double-headed arrow again here, the difference between these two numbers. And our question mark. Now, what we're often looking for in bar modelling questions is to have equal parts. And if we have equal parts, then we know that we're going to be able to do a multiplication or division piece of work. Now, we often find that we don't start with equal parts, but if we make an adjustment to our model, we can have equal parts. So just see what happens here. If we get rid of this 12, which is the difference here, suddenly we see that we have 2 equal parts. So if we ignore this bit here, which is 12, then let's see what happens in the calculations. So instead of the bars adding up to 50, they add up to 38 because we've taken away this part of the bar here, which is 12. And at that point there, we suddenly see that these two parts are equal and they add up to 38. So we can do a division calculation, in this instance, halving divided by 2. And indeed, that takes us straight to our answer. Question 3. Again, let's have a look. How many bars will I need here? Well, this is just about a bag of flour. So I think there's going to be 1 bar for the bag of flour, and we're going to see various parts of it. Now, we're dealing in fifths here, so we really do have equal parts straight away, and that's a big clue to us that we're going to do some multiplication or division here, possibly both. See how the labeling of the bar model is really important here. And we can see that our 360 relates to two equal parts, hence why we've got a division calculation here to tell us what each of those parts are. Now remember, all of these are equal, so straight away that tells us what all the parts of this bar equal. So having done a division calculation, we can now do a multiplication calculation to find out how much was in the bag to start with. Okay, question 4. Well, it looks as if we're going to have 3 bars here because we've got a first, a second, and a third term. So let's see how we go with that. Now, let's have a look at line 1 here. A sequence increases by the same amount each time. Now, an important part of bar modelling is to try and break down our worded question to build our model step by step. And one thing which is worth trying is to see whether actually, if we've incorporated everything that's in that sentence or in this line here, then we don't need to look at it again. So a sequence increases by the same amount each time. Yes, that's included in my model, and it's getting bigger by the same amount each time. So I know that I actually don't need to read that line again. Next line, the difference between the first and third term in the sequence is 18. Okay, so double-headed arrow showing the difference between the first and the third term. Looks if I've included that, so I don't need to read that line again. The sum of the first 3 terms. Now, the sum of, that was our curly bracket from earlier, wasn't it? So let's put in our curly bracket. And the sum of these 3 terms is 60, so I don't need to read that line again. And what is the third term of the sequence? Well, I've now included that. So look, my whole worded question has disappeared, and all I'm left with now is my pictorial model, and that tells me everything I need to know that was in the question. Now, as I've mentioned before, and we've seen it in a couple of questions over the first 2 days, a lot of our work here is trying to get to a situation where we have equal parts. And if we get to a point where we have equal parts, then we can do a multiplication or division calculation. So clearly these bars aren't equal. Let's see what we do to try and get some equal parts. And we start by thinking about this difference here, which is 18. And this was going up by the same amount each time. So this rather tells me that it went up by 9 and then another 9 to get 18, because it was going up by the same amount each time. Now, we now have 3 equal parts, which are 9, but we also now have 3 other equal parts here. So the first thing we're going to do is we're going to get rid of these 3 9s and see what we're going to do with our equal parts that remain. So we can now see that these 3 equal parts come to 33, and we have equal parts, so we can do our division calculation and find that each of these is 11. Okay, so we started with things that weren't equal and did work bit by bit to make sure that we had equal parts at the end, so we could do a division calculation to get our answer. Always worth remembering that we actually need to go away and finish our question, which was how big was the third term, which is 11 and 9 and 9. Okay. So look, that's the end of the solutions for day 2. Hope you're enjoying your bar modelling. If you struggle to do the questions and these solutions have helped, that's great. If you still have questions, then please message your teacher and they will be able to help you and get you on the right track. But enjoy your bar modelling over the next few weeks.